So that first video I did was really long, and I decided to break them up into different subjects. So we're going to look at geometry today. This is really cool. It's going to touch on mechanical engineering, electrical engineering, and computer programming. And it's really going to get the kids hooked on developing their geometry skills and moving into calculus, and but most important, passing the Regents test. And that's what we're all here for. That's most important. The formula and its application in geometry and passing the Regents test. Okay, super quick recap. So this is entrepreneurship and STEM, and this thesis here is that the kids are going to engineer new products and sell them, and that's our fundamental definition for being an entrepreneur. So they're going to be able to discover like a scientist, create like an engineer, and sell like a rock star salesperson like Steve Jobs, Elon Musk, right? So they were basically delivering all those three skill sets. And the kids, what we want to do is lead them down this path and get them to create something that they just get hooked on and say, I'm not going to let this go. I'm going to make this a success. And then we can lead them through any sort of studying or doing any sort of academics that we want them to. And certain schools teach this way. They teach, usually, traditionally, education is you do all the boring work, you don't know why you're doing it, and then you figure out why you're doing it later. This Ivy League schools and some of the new sort of way of teaching is to flip, reverse that. Tell them why they're doing it first, and then teach them the theory and what they need to do. And to the tune of that, tell them, get them to create something and get them to show them that this is how all this academic stuff translates to you making something and you becoming, reaching the land of IPO and becoming a billionaire entrepreneur like Elon Musk, Steve Jobs, Jim Bezos, Jay-Z and Beyonce. I mean, it's translatable to any industry. It's all the same thing. You're creating the product and you're selling it. So that's the thesis, and that's why eSTEM is such a good fit for traditionally underserved populations, because if you look on Instagram right now, everybody is calling themselves an entrepreneur. Everyone. It's a hot button term, and I think academia, the K-12 space, would be, it would just be in everyone's best interest to parlay that into education some way, and this is how we're trying to do that. All right, so once the class heats up and you start giving the kids the tools, the logic statement, and start reverse engineering other products and teaching them how to innovate like an engineer, and they're gonna get, things are gonna start getting pretty sporty. They're gonna start inventing stuff. They're gonna invent some stuff that's gonna have real value, and they're gonna get emotionally connected to it, and they're gonna come after the principal and the teacher and ask, how far can they actually take it? Then can they actually start their own company? They're gonna want to do it, and I liken it to them being like pit bulls on a leash, just like just aggressive. They're gonna get very aggressive, right? And the point here is that once they get emotionally tied into their products, they're not going to want to let it see it die. They're going to feel like, wow, I really came up with a good idea. And that's going to be a catalyst for them to barrel into solving any mathematical formula, doing any business plan competition, writing, reading the Wall Street Journal, because they're not going to want to see this dream die. They're still children. Their hearts aren't broken yet like adults, so they're going to take it and they're going to live the dream, right? And that's when we can literally, just lead them through any mathematical operations, because after they come up with the idea, then they're going to have to make it work. Right? And sort of you can even do it in a makerspace environment. Makerspaces are really big, like a lab where they actually create prototypes. And once they get into the makerspace and try to make it work and test it and want to go out and get funding, and then they're going to have to realize that, wait a minute, I do need math. I do need trigonometry. So let's get into that. And they're going to aggressively go into trigonometry, and this is what's next. Okay, so I studied engineering the hard way, and that's kind of why it was very painful, and that's kind of why I'm so belligerent about this. So to get into it, in mechanical engineering, and I'm an electrical engineer, mechanical engineers and electrical engineers usually work together. They call it working in concert. And the relevance here is that these are the 6 basic machines, right? And what it's basically saying is that every mechanism, whether it's a car or a lawnmower or an airplane, basically are made of these six basic machines, right? And they're models, and there's math to go along with them to calculate how much work they do and how quickly they do it, right? So if you look at the one at the bottom, the inclined plane, sine and cosine, the trig functions that are sort of the precursor to calculus, and that you learn when you a squared plus b squared equals c squared, and and geometry, that it's directly applied there. And there's a guy on the internet who is an electrical engineer, and he's an amazing teacher, and you'll hear him say that we're going to do it teach in the opposite direction, tell you why you use this stuff first, and then show you what it is, right? And I'm going to attach a link with a lesson plan in this PowerPoint so you guys can go and check it out. So these basic machines, you can make anything. You put a little electricity on top of it and some computer programming, and you can make a drone airplane, or you can make a Tesla motor car, basically out of these 6 machines. They never told me this at Northeastern, but we tell the kids this in the class, and then they start to create. And I think this is one of the more amazing lesson plans, because if you want to get kids excited, if you just tell them that every machine that they look to, whether it's a bicycle or a paper or a plane, is made of one or all of these 6 machines, you can make an elevator with these things, right? That just opens up a world for them, and then now they just got to learn the math. All right, so here's some electrical circuitry, pulse and digital, and this is part of physics. So this would lead them into physics. And then you have one of the basic machines, which is a pulley, right? You put some electricity on top of a pulley so you can motorize it like you're making an elevator, and then you add some logic, some computer programming, so you can program it and maybe have it go up and down, and and set up algorithms so that it does things by itself, and make sure that the elevator is not stuck on the 12th floor for hours, right? And this is with logic. So you see the inequalities here. Grade is greater than 70 and grade is less than 80, so they're putting limits there, and that's actually a precursor to investment banking and hedge fund management, but that's a whole other conversation. Logic, that's why a lot of engineers are in that field. So you mix these 3 things together and you can make about any machine, right? You can make just about anything, and the kids going to start making stuff. They're going to start making stuff pretty quick. Now, they're going to be able to conceptualize new products, but then being able to actually create and design it and figure out the math, they'll work tirelessly to do that. And if they could get crowdfunding and start a business plan writing competition. So here we're just looking at, that's basically the the axle, another basic machine, and you can get AutoCAD to show them how to play with that and design it like real engineers. Or they can make just about anything. They can make a drone, or they can redesign the Tesla electric car and make a really cool electric car. And then they can pitch it, and we talk about how their car would differentiate itself from other cars on the market. That's a whole different conversation right now, but for now, just to show you the mathematical application and the engagement, and this is just with the 6 different machines and how they can explore geometry with the plane and the plane, the level plane, right? So this is pretty cool, and as I'm sure you can see, the kids love it. It's just a matter of how far you want to take them with it, and what they're going to do, because they can. They'll take it as far as you allow them. Here, as you can see, we have the logic, circuitry. We have the models. We have the math, and we have what are the 4 things? We have units of measure, right? These are all the fundamental components of being an engineer, right? And you see inside the math, you see limits, you see geometry, you see charting, right? You see functions. All of these things. You even start going into some pre-calculus and looking at limits and stuff like that. So sum totals, right? So basically, these are the hemispheres of engineering, regardless of discipline, right? And you see that your kids are going to be exercising the skills that are needed to pass the Regents test. But the reason why I brought this out and showed you these different categories, the math, the logic, the units of measure, and the models, is because of this next slide. Those 4 hemispheres that we just talked about, the unit of measure, the modeling, the actual math in the middle here, and the logic statement, are all the tools that your kids are going to get just walking in the door learning the formula. All right, so I think this really helps to explain how the formula translates to engineering, how it translates to innovation and engagement of your students, persistence and resolve, emotional intelligence. All these things are going to have to work together in team. You know, they'll get in teams and they'll do their presentations, all of that. But most importantly, it goes right at the components that are going to be needed for them to be successful to pass the Regents in geometry or any math, any math genre, because again, they're going to create something unknowingly, and then when it's time, the rubber meets the road, and they have to actually put it together and understand it to talk technical, talk the talk. They're going to realize, all right, I got to get at this stuff in my math class, in my Regents exam. I got to be able to write it. I got to be able to speak it. I got to be able to calculate it and control it. And those are the elements of the Regents exam. All right. So we give them the why first, and then we give them the how. And hopefully the why and their emotional connection to what they've created gives them the energy to see this through to the finish line. And that's how we can, we can assist in the category of geometry. Thank you so much, and please give me a call if you'd like to hear any more. Last but not least, this is an additional online resource. This gentleman is an electrical engineer, and as you can see, he teaches, or he starts off the lesson plan explaining how sine and cosine is used in practical real-life applications, and then he teaches the math. So this is an amazing resource, and I suggest you share it with your teachers.